Welcome. The topic we'll be discussing in this lecture is dynamic memory allocation. So basically we'll be discussing like how memory can be allocated dynamically in C programming language. Right? So first of all, there is a question. There may be a question like why should we allocate memory dynamically? Before that, what is meant by dynamic memory allocation? So dynamic memory allocation means allocating memory at runtime. If the memory allocation happens during execution time, then that is called as dynamic memory allocation. If the memory allocation happens during compile time, then that is called as normal memory allocation or static memory allocation. If, say for example, uh, say say for example, in a C program, you are writing like this: int s. So this means that s is a variable of type integer. So it means that if this is an instruction to the compiler. The programmer is instructing the compiler to create a variable called s, and some memory should be allocated for s, and this s requires 4 bytes of memory. So maybe the starting address is 4000, and and so I mean starting from address 4000 to 4003 will be allocated for this variable because int occupies 4 bytes. Okay. So when you allocate memory like this, that is called as static memory allocation. Okay? But sometimes what happens in the sense we don't know how much memory is required. Right? So say the program may use either 5 variables or 10 variables or 100 variables or 1000 variables. It depends. Initially, I don't know how much it will need. So in that case, what you can do is you can use an array. So So the context is the number of variables required may vary depending on the program flow. It may be sometimes it may require only just 5 variables, sometimes it may require 50 variables, sometimes it may require 500 variables, or sometimes it may require 1000 variables. In that case, to deal with that, then you can declare an array of maximum size. So you may declare an array of size 10,000. Now what will happen? Okay, this is a static allocation only. But this will create an array of size 10,000 location. So it means that 10,000 location means it's an integer array where each location occupies 4 bytes. So how much bytes should be allocated? 10,000 into 4, 40,000 bytes should be allocated. Are you getting? So so if the starting address is 2000, if the starting address is 2000, then the ending address will be 42,000, right? So, but uh, but another important thing is out of this array, how much locations we are going to use, we don't know. So this is the starting element, and the last element will be uh, so zero. So 10,000 element. So 0 to 9,999 element. This array will hold. But depending on the program flow, sometimes this out of this array you will be using only 5 locations. In that case, all the remaining locations, okay, all the remaining 9,995 locations are wasted. Sometimes it may use only 50 locations. Sometimes it may use only 100 locations. In that case, you are allocating, you are holding this much space that you are not using. So it is a wastage of space and it is not an effective way of programming. Okay? So in such cases, it is advisable to go for dynamic memory allocation. So using dynamic memory allocation in the runtime, on the flow, you can allocate memory. Right? So dynamic memory allocation, how it is done in the sense. So dynamic memory allocation is achieved by using these functions: malloc, calloc, realloc, and free. Using these functions, dynamic memory allocation is done in C programming. So, so how that happens, that we will discuss in this session. And all these are predefined functions. malloc is a predefined function, calloc is a predefined function, realloc is a predefined function, and free is also a predefined function. And all these functions are available in the header file stdlib.h. So if you want to use any of these functions, then the program should include stdlib.h. So as we previously discussed, if you want to use scanf for printf, you should include stdio.h. Similarly, when you want to use malloc, cloc, realoc, or free, you should include stdlib.h. Right? So let us first try to understand how malloc works. So this is the syntax for malloc. PTR is a pointer. Okay, some pointer. It may be an integer pointer or it may be a character pointer. Okay, and then equal to cast type. So here some data type should be specified. If you want to allocate memory for holding integer values, then here you have to give int star. Okay. If you want to allocate memory dynamically, if you want to allocate memory for storing floating point values, then here you have to give float star. If you want to dynamically allocate memory for storing double values, then here you have to give double star like that. And malloc is the actual function. Within bracket, you have to specify how many bytes, how much bytes should be allocated. Okay. So you can directly give a number also here. You can, if you give just 4, it will allocate 4 bytes, where you can store one integer. If it is, if this is int star. If you give 8, it will allocate 8 bytes, where you can store 2 integers. Okay. If you instead of bytes in the byte size place, if you give 64, it will allocate 64 byte, where you can store 8 integers. Okay. So this is the syntax. So here is the example like how normally we use malloc. Here we are declaring 3 pointers, ptr1, ptr2, ptr3. All these are pointers to integer. ptr1 is a pointer to an integer, 2 is also a pointer to an integer, and 3 is also a pointer to an integer. And there is a variable n which is holding the value 4. Okay, this n is a normal integer which contains the value 4. And here now we are dynamically allocating memory for all these pointers. ptr1 is equal to int star malloc size of int. This size of is a function which will give the size of integer. So the size of integer is 4. This integer occupies 4 bytes of memory. So this will return 4. So it means that it allocates malloc 4. This statement will allocate 4 bytes of memory, and whatever the memory allocated, it is typecasted to integer type. That is, in that memory, an integer value can be stored. So this is what this statement will do. It will allocate 4 bytes of memory to store one integer. Say I want to store more than one integer. I want to store 5 integer or 10 integer or 100 or 1000. Then you can follow this syntax. ptr2 equal to int star malloc. Here we are giving 5 into size of integer. What is size of integer? 4. So this is 5 into 4. 5 into 4 means 20. So it will allocate malloc 20. So it means it will allocate 20 bytes of memory. And this 20 bytes of memory, in all these 20 bytes, you can store only integer value. An integer occupies 4 bytes. Okay, integer occupies 4 bytes. So, so 20 by 4 is 5. So this it will allocate 20 bytes of memory, where 5 integer can be stored. Okay. Or instead of this 5 is a constant, or instead you can use a variable also. Here n is a variable. So the third way of using what it says is ptr3 is equal to int star malloc n into size of integer. So here n is 4. Size of integer is also 4. So 4 into 4 is, it will allocate 16 bytes of memory, which can be used to store integer values. So this 16 bytes can be used to store 4 integers. Okay. Right. So this n value may be a user input. So dynamically you can change the n values, maybe based on user input or whatever may be, right? So this is how dynamic memory allocation happens. Assume that n is 40 instead of 4, then how much memory it will allocate? It will allocate 160 bytes of memory, where you can store 40 integers. If you give 400, it will allocate 400 into 4, 1600 bytes of memory, where you can store 400 integers. If you give 4000, it will allocate that much from 4000 into 4, that much bytes memory, where you can store 4000 integers, right? But here only if it is required, only if it is required, then you will change the value of n. So depending on the requirement, the n value can be assigned, and accordingly the memory can be allocated, so the memory will not go waste. You getting? This n you can take it as a user input. Say how much bytes you want to, how many integers you want to use. Like that you can ask the user. If the user says 5, then you can read that in n. Then you allocate memory for 5 integers. If the user says 500, then you assign n to 500. Then allocate memory for 500 integers. Right? 500 locations which can be stored integer value. But you see there is only one pointer. There is only one pointer which is pointing to all these 4 locations or 5 locations. Now, how using this pointer we will access all the lines, that we will discuss with the program. So here is a simple program using malloc. First program, in this program we are using only what do you call? In this program we are using only one variable. Okay, I mean we are not variable. Uh, we are using a pointer which creates memory to hold only one integer. Okay, so we are including two header files, stdio.h and also stdlib.h, and there is a pointer ptr1, and n is assigned with 5. Then we are saying ptr1 is equal to int star mlf size of int. So you know the size of int is 4. So this will allocate 4 bytes of memory, which is used to hold an integer. Then we are asking the user to enter a value, and whatever the value the user gives, that is stored in ptr1. So sorry, I missed the ampersand here. Here ampersand is there, right? So scanf. Sorry. Ampersand is not required. Ampersand is not required because ptr is a pointer, and pointer always points to an address, right? So ampersand is not required. So the logic is whatever the code is correct. So what happens in the sense ptr is equal to int star mlf size of int means 4 bytes will be allocated, and that 4 byte will be pointed by the pointer ptr1. So ptr1 is a pointer. Okay, say the address of ptr1 is 2000, and this memory int star mlf size of int, it allocates 4 bytes of memory. Say the starting address of this is 1000. 4 bytes out of the 4 bytes, say the first address is 1000, then the last address will be 1003. Okay, so it means that when you say ptr1 is equal to int star mlf size of int, it means that ptr1 will be holding 1000. That means that ptr1 is pointing here. Okay, ptr1 is pointing here. So ptr1 contains 1000. So printf enter a value scanf percentage d ptr1 means it refers 1000. So whatever the user gives input, it will be stored in the location 1000. Say the user gives the value as 697. So that will be stored in this location. Okay. And now we want to display the whatever the value we read. So we are using the printf. Printf, the value entered is percentage d star ptr1. Star represents value at location. What is ptr1? 1000. Star represents value at 1000. What is the value at 1000? 697. So it will display 697, return 0. Okay. So it's a very simple program which dynamically allocates the memory for holding one integer. Next, let us see how can we dynamically allocate memory for holding more than one integer. So I want to hold more than one integer, 5 integers or 10 integers, whatever it may be. Then how to do? So again, we are including the header files stdio.h and stdlib.h. This is the main function. We are creating a pointer ptr1 for integer, and there is a variable n which is assigned with 5. But this n can be changed dynamically, and there is a variable I for loop control, because now we want to create a dynamically memory for holding 5 integer values. Okay, so we are going to use a loop here. Okay. So what we are doing, we are allocating memory. So Let us understand at this point what will happen. Let us first understand when this statement is just when this statement is executed, what will happen. Some memory will be allocated for ptr1. Some memory will be allocated for ptr1. Okay. Say the address is 2000. Address is 2000. ptr1 is a pointer. Okay. And n is a variable. So for n also some memory is allocated. N is an integer variable. Okay. So it 4 bytes will be allocated. Say its starting address is 5000. Its ending address will be 5003. Okay. And it is holding the value 5. Similarly, for I also memory is allocated. Okay. Then when you give this statement, int star mlog n into size of int, then what happens? Size of int is 4, n is 5, so 5 fours are 20. It will allocate 20 bytes of memory, which can hold integer values. So it will allocate 20 bytes of memory, which can hold 5 integer values. So it will allocate 20 bytes of memory, which can hold 5 integer values. Okay. So this location can hold 5 integers: 1, 2, 3, 4, and 4. Okay. And each location size is 4 bytes. So this is 4 bytes. Like that, everything is a 4-byte location. Okay. So so if the starting address is 1000, if the starting address is 1000, okay, then this will be 1003. Okay, 1003. Next will be 1004, 5, 6, and 1007. Up to 4 to 7. Okay. Next will be 8, 9, 10, and 11. Okay. So that will be up to 1011. Okay. Next will be 12, 13, 14, up to 1015. Next will be 16, 17, 18, 19, 1019. Okay. So like that, the memory is allocated. Right. So this is 1015. Uh, this is 1003. This is 1007. Okay. This is 1007. This is 1011. So this is 15. Okay. So this is how the memory is allocated, right? And where the PTR is pointing, PTR will be holding the starting address, whatever the starting address 1000. Okay, so it means that PTR is pointing to the first location. Okay. Now we want to read the values for all the 4 locations, and then we want to display them. So we are asking the five locations. We are asking the user to enter 5 values. We are running a for loop for I is equal to 0, I less than n, I plus plus. Okay. So if you recollect in the last class, whatever we used, that logic we are using. Scanf percentage %d ptr1 plus I. So initially what is I? I is 0. What is ptr1? 1000. So what is 1000 plus 0? 1000 plus 0 is 1000. That's it. Okay. Of course, the scaling factor is there. Scaling factor is 4 because it's integer. So 1000 plus 0 into 4 is, it is 1000 only. So the first value, whatever the input the user gives, that will go into this location, 1000 to 1003. So the first input is 12. When the loop goes for the next round, I becomes 1. So now it is 1000 plus 1. 1000 plus 1. But you should use the uh, but you should use that I mean scale factor. Okay, so 1 into 4. So 1000 plus 1 into 4. So 1000 plus 4 is 1004. So the second location is the second location starts at 1004 and it ends at 1007. So whatever the value you give for the second input, say 36, it will come here. Right? Okay. Then the third, when I is 2, it will be 1000 plus 2 into 4, okay, which is nothing but 1008. Okay. So the third input will come here, say 72. Okay, then the fourth is, it is I is equal to 3. because loop starts with 0. So 0 fourth value is 3. The index is 3. So 3 into, so 2 into 4 is 8. 3 into 4 is 12. So 1012. So here the next value is 2. Say 40. In the last value, fifth value will be stored at fourth index location, which is 1000 plus 4 into 4, which is nothing but 1016. Okay, so 1016, the last value will be stored. Say it is 32. Okay. Like this, the inputs will be read. Now, say we want to display that. When again you use a for loop, the contents are for I is equal to 0 less than n I plus plus scan of percentage d ptr 1 plus I. Before that, use star. That's all. Initially, I is 0. So when I is 0, it is nothing but this. Okay. So PTR is this. Star PTR is what? Value at this. Value at 1000 is 12. We'll display it. Then in the next round, I is 1. So I is 1 is this. 1000 plus 1 into 4 is 1004. So star PTR is value at 1004. What's the value? 36. We will display. Then in the next round, I is 2. Okay. So 1000 plus 2 into 4 is 1008. So that is the address. Star 1008 is value at 1008. That is 72. Display that. Then the next is 1000 plus 3 into 4. That is 1012. So value at 1012 is 40. The next 1000 plus 4 into 4, it is 1060. So there is a star. You can see the star is here. So 1000 plus, that is value at 1016 is 32. Okay. So that is what it will display. So this is how malloc works, right? Okay. So, so there is also another function which is used to, okay, before that, then finally we are giving free of ptr1. This free is a function which is used to free the allocated memory. So whatever the memory allocated for ptr1. So as we have shown in that whatever. So ptr1 was allocated. Uh, ptr1 is pointing to locations which can hold 5 integers. So all this memory will be free. So that is what the 3 will do. Okay. Now PTR is not pointing. Even though now PTR is becoming, now PTR is not, PTR cannot access this location. Okay, this because this location is already freed. Right? So this is called as dangling pointer. Because originally PTR is pointing here, but now you freed that. It means some other program can use that. So it becomes a dangling pointer. Okay. So this is how we free the memory allocated. Right? Okay. The next thing what we are going to discuss is how to dynamically allocate memory using CLOC. Okay. So C basically provides two functions for dynamically allocating memory. One is malloc, the other one is CLOC. So what's the difference between malloc and CLOC? You may ask. So the difference is the difference between malloc and CLOC is malloc will allocate memory, but whatever the allocated memory, say here we allocated 5 locations where integer values can be stored. But all these 5 locations, it may have some garbage values. These garbage values will not be cleaned. Say the as we discussed, say the starting address is 1000 and the ending address is 1019. So this much memory is allocated, 20 bytes, 5 fours are 20. Okay. Now already this location may have some value. Say that this location is having something A, B, C. This is having something 1, 2, 3. So these garbage values will not be cleaned by malloc. It will allocate along with the garbage value. So that is what malloc will do. Okay. But if you allocate memory using CLOC, if you allocate 5 bytes of, I mean, 5 locations where you can store integer values using CLOC, probably say this is allocating from 2000 to 2019. Okay, then what CLOC will do is CLOC will not only just allocate memory. After allocating memory, it will fill all those locations with zeros. After allocating memory, it will fill all those locations with zeros. That is, it will remove all the garbage values and it will fill it with zeros. Okay. So this is the difference between malloc and CLOC. CLOC will allocate just memory. It won't clear the garbage values. Sorry, malloc will allocate just memory. It won't clear the garbage values. Whereas cloc will allocate memory, and whatever the locations it is allocated, it will be filled with zeros. That means it will clear all the garbage values. Okay. So the C in cloc stands for clear the garbage value, clear the garbage values and allocate memory. That's what C stands. Okay. And in the syntax also, it slightly differs. So this is the syntax. PTR is some type of pointer equal to cache type, which is type any data type for which type of what type of data you want to store in the memory, and then cloc within bracket n comma element size. So here n represents how many locations you want to allocate. Okay. Say if n is 4, okay, if n is 4 and this is also 4, okay, then it will allocate 4 into 4, 16 bytes of memory it will allocate. Okay, like that it will allocate. So here element size represents what type of value you want to store. Okay, so element size is 4 for integer. Okay, so it will, so this is used to allocate memory for storing 4 integers. If you want to allocate memory for storing only one integer, then you give 1 comma 4. If you want to allocate memory for storing one double value, then you can give 1 comma 8, or you can give 1 comma size of float or size of double, like that. Right? So, so if you want to allocate memory for storing one double, then we give 1 comma size of double. Size of double. Right? If we want to allocate memory for storing four double values, then we'll give 1 comma size of double. Okay. Right. So this is the example. Again, we are creating 3 pointers ptr1, 2, and 3, and there is a variable n which is assigned with 4. Okay, if you want to allocate memory for holding only one integer, then you do like this: ptr1 equal to int star cloc 1 comma size of integer. The size of integer is 4. So 1 into 4 is 4. It will allocate 4 bytes of memory to store one integer. If you want to allocate memory for storing 5 integers, then you can give like this: ptr equal to int star cloc 5 comma size of int. Okay. So size of int is 4. Okay, like that, size of int is 4. Like that, 5 units of memory it will allocate. Okay, size of int is 4. Like that, it will allocate 5 units. So totally 20 bytes will be allocated, where 5 integers can be stored. Okay, or you can use like this: ptr3 is equal to int star cloc n comma size of int. So size of int is 4. Okay, so 4 bytes of memory will be allocated. Like how many units? N units of 4 bytes of memory. Okay, so here n is 4. It will allocate 16 bytes to store 4 integers. Right? So other than that, everything is same. So here you need not use store. You can just say 1 comma size of int, which will allocate memory for storing one integer. 5 comma size of int, which will allocate memory for storing 5 integers. N comma size of int, which will allocate memory for storing n integers. Okay. Fine. So what would be the syntax for storing 5 float values? You can say there is a pointer ptr4. Okay. So there is a pointer float. Okay. Store ptr4. Now, how will you write the code to allocate memory, to dynamically allocate memory for storing 5 floating point values? Okay, you should dynamically allocate memory where 5 floating point values can be stored. So this you can try as a small assessment. You try. What will you write? ptr4 equal to dash. ptr4 is equal to dash. You can try this. Okay. What will you write? Check. So here is an example code for cloc. Oh, sorry, this is not M, this is C. Okay. Here is example code for cloc. hash include stdio.h, stdlib.h, and there is a pointer ptr1. N is assigned with 5, and this loop variable I is there. Okay. Then okay, okay. There is a loop variable I, and then we are saying ptr1 is equal to int star cloc n comma size of int. So what this will do? This will allocate size of int is what is size of int is 4. So it and n is 5. So it will allocate n units of 4 bytes of memory. Okay, that is, it will allocate 5 units of 4 bytes of memory, which is nothing but 20 bytes. It will allocate 20 bytes of memory for storing 5 integers: 1, 2, 3, 4, 5. It can hold 5 integers: 1, 2, 3, 4, 5. Okay, and the starting address, say the starting address of this entire unit of memory is 2000. Then ptr1 will be holding 2000. Okay, ptr1 is the pointer. So this pointer ptr1, now it will hold the value 2000. So it means that ptr1 is pointing to this location. Okay. Now how to read the values and display? It's very similar like malloc. There is no difference. Only the syntax changes. Okay. So ask the user to enter 5 values. Then for I is equal to 0, I less than n, I plus plus, scan of percentage d ptr1 plus I. So the explanation is very similar. ptr1 is 2000, so I is 0, so which means the first value will go to 2000. Okay, here. And the second value, by the time I will become 1, so ptr1 plus 1 is, that is, scale factor is 4. So 1 into 4 is 4. So 2000 plus 4 is 2004. So the second value will go here. Okay? And the third value, I is 2. So the scale factor is 4, 2 into 4, 8. So 2000 plus 8, 2008. Third value will come here. Okay. And the fourth value, I is 3. Uh, I is 3 and the scale factor is 4. So 3 fours are 12. PTR1 plus 12. Fourth value will come here. And the fifth value, I is 5. Scale factor is 4. Okay. Sorry, I is 4. I is 4. But the fifth value, I is 4. Scale factor is 4. 4 into 4, 16. So PTR1, that is 2000 plus 16. So the fifth value will come here. And then we display, instead of using just ptr1 plus I, you add a star info. Star represents value at location. When I is 0, star ptr1 is 1000, so value at 1000, this will be printed whatever it here. Then ptr1 plus 1, that is 2000 plus 1 into 4, that is value at 2004 will be displayed. Okay. Then ptr1 plus 2, that is 2 into 48, value at 2008 will be displayed. So on and so forth. It continues. Okay. And finally, we free this memory through this syntax free of ptr1. Now this entire memory will be free. Okay. So, and ptr1 becomes a dangling pointer, right? So return 0. That's it. So whenever you dynamically allocate memory, it is always advisable to free the memory. Okay. Why we are freeing means it's a good programming practice, because some other program may want memory. So operating, it is a signal to the operating system that I no more want this memory. It means that it is reserved for this program, but this program is telling I am done with whatever I am doing. If operating system want to use this memory for some other purpose, it can proceed. That is what the meaning of free. Okay, fine. So let us stop here. You can try these programs, and in tomorrow's class, I will show you the execution of this program.